All right, strap in, everyone. We're going deep on PCIe today. Well, not the usual stuff you hear about.
Right, right.
We're diving into a performance-boosting feature called TPH. That's Transaction Layer Packet Processing Hints.
Hits. Yeah.
We're going beyond the basics. We've got some seriously in-depth technical reports to guide us. And trust me,
Oh, yeah.
by the end of this, you'll be tossing around terms like steering tags, like a pro, ready to unlock a secret level of performance in your devices.
Absolutely. Let's get into it. We're going to be talking about squeezing every ounce of speed and efficiency out of your systems. It's the magic that makes your computer hum.
Okay, before we get too deep in the weeds here,
Sure.
what exactly are these hints we're talking about?
Okay, so in simple terms, TPH optimizes data flow, like how data moves within your computer.
Okay.
It attaches these things called steering tags to data packets, kind of like a priority label telling the system, hey, handle this data this way for the best speed and efficiency.
So like a VIP pass for data, making sure it gets to the front of the line.
More like a personalized roadmap. These tags are telling the system where the data needs to go and what needs to be done with it. It's all about avoiding digital traffic jams.
Okay, I'm starting to see the picture here.
Yeah.
But why was TPH even necessary? Like, was there a problem it was specifically designed to solve?
As CPUs got more powerful and our applications started demanding more data, the way it moved around started to become a bottleneck. It's like imagine a superhighway suddenly shrinking to a single lane.
Ouch, that's a recipe for a digital gridlock for sure.
Exactly. TPH, which was introduced in PCIe 3.0, basically expanded that highway. It made data flow more efficient.
Okay, walk me through how this works on a technical level.
Yeah.
How does TPH actually prevent these digital traffic jams?
Okay, it all starts with the endpoint device. That could be your network card, SSD, you name it.
Right.
Based on what the data is and where it's going, this device generates a steering tag.
So sticking with the roadmap analogy, it's like picking the fastest route based on your destination and what you're carrying.
Right. Precisely. This tag gets attached to the data packet's header. Think of it like instructions on a package.
Right.
Then as this packet moves through the system, each component, the controllers, switches, endpoints, they all read the tag and prioritize and route the data based on that.
Okay, so it's like a super smart postal service that knows the best way to route each package. Where exactly is this TPH used? Is this something we're likely to encounter in our everyday tech?
Absolutely. TPH is quietly working behind the scenes in tons of devices you probably use every day.
Okay, I'm intrigued. Give me some examples.
Take high-performance computing, for example. Supercomputers, the ones used for crazy calculations and research, use TPH to manage all that data they have to process, making sure those computations happen super fast. We're talking groundbreaking discoveries, maybe even cures for diseases, all thanks to optimized data flow.
Wow, that's pretty amazing. What else?
Data centers are another great example. They rely on TPH to streamline the data moving between servers. This boosts efficiency and reduces latency, which is critical for things like cloud computing and online services.
So TPH is helping ensure those Netflix streams run smoothly, our emails arrive on time. It's working behind the scenes to keep our digital lives running.
Exactly. And it's not just these massive applications. TPH is also vital for applications where even a tiny delay can cause big problems, like real-time financial trading or industrial automation.
Wow, so systems where a hiccup could have real-world consequences. How does TPH help in those high-stakes scenarios?
By minimizing delays and ensuring the data gets to its destination as fast as possible, TPH helps keep these systems running reliably. It's like having a dedicated express lane for the most critical data, ensuring those crucial operations aren't held back.
Okay, I'm starting to understand how essential TPH is to everything we do digitally, but can you give me some specific examples of TPH at work in devices we might actually use?
Absolutely. So high-speed network adapters, they use TPH to direct all that incoming network traffic. This cuts down processing time and allows for faster data transfer. Ever notice how much faster downloads are these days? TPH is probably playing a part in that.
So that's why my files download at lightning speed. What about storage devices?
NVMe SSDs, which are known for their speed, they leverage TPH to optimize data transfers. That instant access feeling you get when you open a file. TPH is probably at work there too.
Wow, it's incredible how much we take for granted. This is really opening my eyes to all the hidden complexity behind the technology we use daily. You know, earlier you mentioned something called AMD Smart Data Cache Injection, or SDCI. Can you tell me more about that?
STCI is a great example of how TPH is being innovated upon. It's found in AMD's 5th Gen EPYC Turin platform. It allows data from I/O devices like network cards or storage drives to be directly inserted to the CPU's L3 cache.
Okay, so instead of going through the usual route, it's like taking a shortcut straight to your destination. But why is this such a big deal?
Because the L3 cache is insanely fast compared to main memory. This results in a major performance jump, especially for applications that are heavily reliant on data transfers between I/O devices and the CPU.
So things like gaming, video editing, even browsing the web would benefit from this.
Absolutely. Anything that involves a lot of back and forth between the CPU and other devices can see a noticeable improvement with SDCI.
It sounds like TPH is really key to unlocking the potential of modern hardware. But beyond all the technical details, what does this all mean for the average user? What kind of real-world performance gains are we talking about?
Well, benchmarks have shown that TPH can cut down latency significantly, sometimes by as much as 50% in certain situations.
50%? Wow. Can you explain what that actually means for a user, like in everyday use?
Imagine you're opening a huge file, or loading a graphically demanding game, or processing a complex data set. With TPH, those things just happen so much faster. It's the difference between waiting and getting things done instantly.
So it's not just some theoretical speed increase. It's about making our computers feel snappier, more responsive, and more enjoyable to use.
Exactly. TPH is all about making our digital lives smoother and more efficient.
That's awesome. I imagine there are some challenges when you're trying to implement a technology this complex. What are some things developers need to consider when incorporating TPH into their designs?
Well, one of the most crucial things is accurate hint generation.
Makes sense.
Inaccurate hints can actually make performance worse.
Oh, wow. So it's like giving someone bad directions, sending them on a wild goose chase.
Exactly. Developers need to really understand the data and create hints that actually reflect its nature. Another key factor is efficient hint processing.
So you can't just generate the hints. The system also has to be able to understand and act on them quickly.
Exactly. If the hint processing itself becomes a bottleneck, the benefits of TPH are lost. And finally, it's important to remember that TPH works best when it's implemented across the entire system.
So it's not just about individual components being TPH aware. The whole system needs to work in harmony.
Right. When TPH is properly implemented system-wide, that's when you see the really impressive results.
It's really fascinating how much effort goes into optimizing something that most users will never even be aware of. That's what I love about these deep dives. We get to appreciate the hidden brilliance behind everyday technology.
Speaking of brilliance, it's worth noting that while the core functionality of TPH is defined by the PCI SIG, different vendors often implement it in unique and innovative ways.
So there's room for customization and further optimization.
Absolutely. Companies like AMD, Intel, and others are always pushing the boundaries of TPH, coming up with new ways to optimize data flow and enhance performance. AMD's SDCI, which we talked about earlier, is a perfect example.
Okay, we've explored what TPH is and how it works, even gotten a glimpse of its real-world impact. Now I'm curious about the when. When did TPH first appear, and how has it changed over time?
TPH was officially introduced as part of the PCIe 3.0 specification, which was released way back in 2010.
So it's been around for a while. I imagine it's undergone some changes since then.
You're absolutely right. TPH, like PCIe technology itself, has evolved with each new generation. It's become more versatile, more adaptable, with tons of improvements to its functionality.
Can you give me some specifics? How has TPH actually evolved?
In the early days, TPH hints were mostly used to speed up data transfers to and from memory. But as the demands on PCIe grew, so did the need for more complex hint generation and processing.
I see.
Newer versions of PCIe allow for much more control over how those TPH hints are used, which lets developers really fine-tune performance for different applications.
So it's become more targeted and efficient.
Exactly. And as we move towards even faster and more complex PCIe technologies, we can expect TPH to keep evolving and play an even bigger role in optimizing data flow.
It's fascinating to see how far we've come. Have there been any roadblocks or challenges in the development of TPH?
Ensuring compatibility across different hardware platforms has been a challenge. Different vendors might have their own ways of implementing TPH, and this can lead to interoperability issues.
It's like trying to fit puzzle pieces from different sets together.
Yeah, that's a good way to put it. But industry groups like the PCI SIG have been working hard to develop standards and guidelines to ensure things work together smoothly.
It's like they're creating a universal language for TPH so everyone can understand each other.
Exactly. Another challenge has been educating developers about the advantages of TPH and how to use it effectively. It's a relatively new technology, and it takes time for people to fully understand its potential.
It's like any new tool, it takes practice to master it.
Right. But as more and more developers become aware of the performance gains, we're seeing wider adoption and more creative applications.
It's great to see how this technology is evolving, but I'm also curious about the bigger picture. What does the future hold for TPH? Where do you see this technology heading?
I think we're just starting to scratch the surface of what TPH can do. As our need for data keeps growing and new technologies pop up, TPH is going to be crucial in making sure all that data flows smoothly and efficiently.
So TPH is here to stay.
Absolutely. And I think we'll see even smarter ways of generating hints, allowing for super precise control over data.
So even more detailed roadmaps for our data.
Exactly. We'll probably see TPH being more tightly integrated with other technologies like NVMe and SRIOV to boost performance and efficiency even further.
It sounds like TPH is going to play a key role in the future of computing.
I think so too. Wider adoption of TPH could lead to a new era of computing where data just flows seamlessly and systems operate at their peak.
It's a really exciting prospect. We've covered a lot of ground in this first part of our depth dive. We've gone from the basics of TPH to its real-world impact and even glimpsed its future potential.
We've seen how TPH is already impacting our daily lives, often without us even realizing it. It's a testament to the incredible ingenuity behind the technologies we depend on.
Exactly. So before I move on to the next part, let's recap some of the key things we've learned. TPH, or Transaction Layer Packet Processing Hints, is a feature in PCIe that allows devices to give hints on how data should be processed and routed. These hints, called steering tags, are embedded in data packets and basically tell the system the best way to optimize data flow for better performance.
We've learned that TPH can dramatically reduce latency, improve how we use bandwidth, and enhance the efficiency of data-intensive applications.
And we've seen real-world examples of how TPH is used in everything from massive supercomputers and data centers to the devices we use daily, like network cards and SSDs.
Perhaps most importantly, we've gotten a deeper appreciation for how complex our technology is and all the constant innovation happening behind the scenes to make our digital lives faster, smoother, and more efficient.
Well said. And with that, we'll wrap up part 1 of our deep dive into TPH. Stay tuned for part 2, where we'll dig even deeper into the technical details, exploring the different types of TPH hints, the architectural considerations, and some of the security implications.
We'll also be taking a close look at the performance benefits, with real-world benchmarks and case studies to illustrate its impact. So join us for part 2, where we'll continue to unravel the fascinating world of PCIe optimization.
See you soon. Welcome back, everyone. In part 1, we talked about the what and why of TPH. Now we're going to go even deeper into the how. Are you ready to decode the inner workings of this PCIe performance booster?
Absolutely. Let's unravel the mysteries of TPH and see how it all fits together.
Okay, you mentioned steering tags in part 1. Are there different types of these tags, or is it just a one-size-fits-all thing?
It's more like a toolbox, different tools for different jobs. There are actually several types of TPH hints, and each one is designed for a specific situation.
I'm all about using the right tool for the job. Can you break down these different hint types for me?
One of the most common types is the no steering tag mode, or NS mode.
NS mode, okay.
It basically signals that there's no special steering information needed. It's like sending a letter with just the address on it. The Postal Service will handle it using their standard procedures.
So when would you use NS mode if there's no specific guidance?
Think of it as the default setting. It's useful when the device sending the data doesn't have any specific knowledge about it, or when the system's standard handling is enough.
That makes sense. So what other types of hints are out there?
We have the interrupt vector mode, or IV mode. In this mode, the steering tag is linked to a specific interrupt vector.
So instead of just general delivery, it's like sending a package that needs a signature, requires a specific action.
That's a good way to think about it. By providing this specific information, the system can prioritize those interrupt-related data packets and route them more efficiently, which can make a big difference in responsiveness.
It's like ensuring those time-sensitive interrupts get express delivery. What other types of hints do we have in this TPH toolbox?
There's also device-specific mode, or DS mode. This mode gives device manufacturers the ability to create their own custom steering tag formats.
So it's like a wildcard option, allowing for more tailored instructions depending on the device and the data.
Exactly. This customization lets developers fine-tune data flow for their specific hardware and the applications they're designing.
Okay, so we have all these different types of hints, each with its own purpose. How does the system know which hint to use in each situation?
Well, that's where the hint generation logic comes into play. The endpoint device, like your network card or SSD, has built-in intelligence to figure out the best hint to use. It looks at the data and its characteristics.
So it's like the device is deciding on the best shipping method for each packet of data.
Right, like if the data is associated with an interrupt, the device would generate an IV mode hint. If it's regular data, no special needs, it'd probably use the NS mode.
Okay, so we've got these hints being generated, but how do they actually get from the device to the rest of the system?
That's where hint encoding and decoding come in. Remember those steering tags, the ones attached to the data packet's header? They have to be encoded in a format that the entire system can understand.
Like translating the instructions into a universal language that the whole postal system uses.
Exactly. And on the receiving end, the system has to be able to decode these tags and extract the steering information.
It's like the postal worker reading the label to figure out where the package goes.
Precisely. The PCI SIG specifications lay out the standard format for this encoding and decoding. This ensures different devices and systems can all communicate with each other. But there's also some room for companies to do things their own way.
So some companies might add their own unique twist to the process.
Right, they might use their own encoding schemes or add some extra information to the tags, but the core functionality is still based on that PCI SIG standard.
Okay, so the hints are generated, encoded, sent out, and then decoded. What happens next? How does the system actually put this information to work and optimize the data flow?
That's where hint processing and utilization come in. Different components in the system, like PCIe controllers, switches, endpoints, they're all designed to read these hints and then change their behavior accordingly. It's a bit like air traffic control, using flight plans to manage all those airplanes.
So, based on the hint, a component might prioritize a specific data packet, send it to a particular place, or even allocate resources differently.
Exactly. It's about making real-time decisions to keep that data moving smoothly and efficiently.
This is a lot more intricate than I initially thought. Are there any specific hardware or software parts that are absolutely essential for TPH to work properly?
Absolutely. The PCIe controller is one of the main players here.
That's the chip that manages the whole PCIe connection, right?
Right. PCIe controllers, both in the endpoint devices and the root complexes, they're responsible for generating, embedding, and interpreting those TPH hints.
So they're like the brains of the operation, making sure those hints are created, understood, and acted upon. What about the PCIe switch? What does it do?
PCIe switches are crucial for directing traffic between different PCIe devices. They use the TPH hints to make smart routing decisions, kind of like a traffic cop directing cars to the correct lane.
So without them, those data packets might get lost in the system.
Exactly. And of course, the endpoint devices themselves play a big role. After all, they're the ones creating the hints in the first place.
It's a real team effort, each component doing its part to ensure efficient data flow. But I'm curious, is there any specific software involved in making this all happen?
Yes, definitely. Device drivers are crucial. They allow your operating system to communicate with the hardware, and they're in charge of configuring and managing TPH in those endpoint devices.
So they're like translators, making sure the hardware and operating system can understand each other.
That's a great analogy. And the operating system itself has built-in support for TPH through different modules and interfaces.
Okay, so it's a real partnership between the hardware and software to make this all work. You mentioned the performance benefits of TPH in part 1. Can we dive a bit deeper into what those benefits actually look like in real-world use?
Of course. One of the most noticeable improvements is reduced latency.
Which, if I remember correctly, is the delay between a request and a response.
That's right. By making data flow better and removing bottlenecks, TPH can really cut down on that latency.
So things like opening files, loading applications, even gaming, all of those could become faster and more responsive.
Exactly. Any task that involves transferring data between different parts of the system could see a significant improvement. Another big plus is better bandwidth utilization.
So we're talking about making the most of the available data transfer capacity, like making sure all lanes on the highway are being used efficiently.
That's a good way to think about it. TPH helps ensure data is transferred as efficiently as possible, preventing congestion and maximizing bandwidth use. And in some cases, TPH can even make things more energy efficient.
Wait, really? How does optimizing data flow lead to using less power?
By reducing unnecessary data movement and resource usage, TPH can help lower the overall energy demands of the system.
So it's not just about speed and efficiency, it's also about making computing more environmentally friendly.
That's right. TPH can contribute to a more sustainable computing experience.
Okay, so we've got reduced latency, better bandwidth utilization, and even energy efficiency. Those are some serious benefits. Are these just theoretical improvements, or do we have real-world examples where TPH has made a noticeable difference?
Oh, there are plenty of real-world examples where TPH has shown it can really boost performance. For instance, in high-performance computing, TPH optimizes the way data moves between different nodes in a cluster.
So those massive supercomputers used for scientific research and complex simulations are running even faster thanks to TPH.
Exactly. And data centers are another area where TPH has made a big impact. Data centers need lightning-fast data transfer between servers, storage, and network interfaces.
It's all about moving massive amounts of data quickly and reliably.
Right. And TPH helps make that happen. By optimizing data flow, it reduces latency, improves throughput, and just makes data centers more efficient overall.
So our cloud services, online applications, and even streaming services are all running smoother because of TPH working behind the scenes.
Absolutely. And the benefits go beyond just those large-scale applications. TPH has been a big help in consumer devices, especially gaming PCs.
Okay, now you're speaking my language. How does TPH help gamers like me get an edge?
TPH can reduce lag and improve data transfer speeds between the CPU, GPU, and storage, which leads to smoother gameplay and faster loading times.
So less time waiting around and more time actually playing the game. I'm sold.
Exactly. It's important to remember, though, that the performance gains you get from TPH can change depending on the specific application and what kind of hardware you have. But in general, it's a powerful tool for improving performance across a wide range of situations.
Okay, I'm completely convinced that TPH is a game changer. But you mentioned earlier that it needs to work together with other PCI technologies to get the best results. Can you give me some examples of how TPH interacts with other features in the PCIe world?
Sure. TPH can be used with something called traffic classes to prioritize different types of data.
So it's like setting up dedicated lanes on a highway for different kinds of vehicles, making sure the most important traffic gets through quickly.
That's a great way to put it. And TPH can also be used with virtual channels to optimize data flow and resource allocation even further.
Virtual channels. Can you explain that a bit more?
Imagine virtual channels as separate pipelines within the PCIe connection, each dedicated to a specific task or device. TPH helps optimize data flow within these individual channels, making everything even more efficient.
So it's like setting up sublanes within the main highway lanes, allowing for even more precise control over the traffic.
You got it. And lastly, TPH can work with quality of service mechanisms, or QoS, to provide different service levels for different applications or traffic flows.
So it's like giving priority to certain data, like ambulances on the highway.
Precisely. By working together with all these technologies, TPH contributes to a super optimized PCIe environment.
Okay, teamwork makes the dream work. Are there any specific relationships between TPH and other PCIe technologies that are especially interesting or important?
There's an interesting connection between TPH and something called Single Root I/O Virtualization, or SRIOV.
SRIOV, remind me what that is again.
SRIOV allows a single PCIe device to be shared among multiple electrical machines. It's basically like splitting a physical device into several virtual ones.
So it's kind of like turning one lane on the highway into multiple virtual lanes.
Exactly. TPH can be used in SRIOV setups to make resource allocation for each virtual machine more efficient.
So each virtual machine gets its own dedicated lane on the highway, making sure they don't get in each other's way.
That's a great way to visualize it. It helps ensure that each virtual machine gets the resources it needs without causing conflicts. Another interesting relationship is with address translation services, or ATS.
Address translation. I remember that vaguely from my computer science days. What exactly does it do?
Address translation is all about converting virtual memory addresses into physical ones. It's a crucial process, but it can be a bit time-consuming.
So ATS steps in to speed things up.
Exactly. And TPH can work alongside ATS to make the whole process even smoother. By providing hints about which memory regions are being accessed, TPH helps devices make better decisions about address translation.
It's like giving the delivery driver a detailed map of the city so they can find the right address faster.
Perfect analogy. TPH and ATS working together can really make a big difference in the efficiency of address translation. It reduces the overall load on the system.
I'm starting to appreciate just how intricate and interconnected all these technologies are. Are there any best practices or techniques that developers should keep in mind when they're working with TPH?
Absolutely. One of the most important things is to make sure the hint generation is accurate. We touched on this before, but it's worth emphasizing.
Right, because inaccurate hints could actually end up slowing things down instead of speeding them up.
Exactly. Developers need to really analyze the data and make sure the hints they create accurately reflect what that data is all about. Another key factor is making sure that hint processing is efficient.
So it's not enough to just create the hints. The system also needs to be able to understand and act on those hints quickly, right?
Exactly. If hint processing becomes a bottleneck, you lose all the benefits of using TPH in the first place. And finally, it's important to remember that TPH is most effective when it's implemented across the entire system.
So it's not just about individual components being TPH aware. The entire system needs to be in sync.
That's right. When TPH is implemented well, at the system level, that's when you see the most impressive performance improvements.
It's fascinating to see how much effort goes into optimizing something that most users will never even know about. But speaking of the brilliant minds behind TPH, are there any particular companies or organizations that are leading the charge in its development and adoption?
The PCI SIG, the organization that's responsible for the PCIe standard, plays a big role in defining and promoting TPH. They're the ones who set the standards and guidelines to make sure everything works together smoothly.
So they're like the rule makers, making sure everyone is playing by the same rules.
Exactly. And as for companies, big players like AMD, Intel, and NVIDIA are all deeply involved in developing and implementing TPH in their products.
So these are the companies pushing the boundaries of what's possible with TPH.
They're constantly innovating and finding new ways to use TPH to enhance performance and efficiency. Companies like Mellanox and Broadcom, which specialize in networking and storage, are also making big contributions to the TPH world.
It's like a collaborative effort across the tech industry. But before we look too far ahead, let's rewind a bit. What's the story of TPH? Has its development and adoption been smooth sailing all along?
Like with any new technology, TPH has had its share of challenges along the way. One of the biggest hurdles has been ensuring it works well across different hardware platforms.
Because different companies might have slightly different ways of implementing TPH.
Exactly. And those variations can sometimes cause compatibility issues. But over time, the industry has made great progress in overcoming those hurdles. The PCI SIG, with its standards and guidelines, has been a key player in making sure things work together seamlessly.
So they're helping to make sure all the pieces of the puzzle fit together. But besides compatibility, have there been any other challenges in the journey of TPH?
Another challenge has been getting developers and system designers up to speed on the benefits of TPH and how to implement it effectively. Since it's a relatively new technology, it takes time for people to fully grasp its potential and learn the best ways to incorporate it into their designs.
It's like any new tool or technique. There's a learning curve before people can really master it and use its full power.
Exactly. But as more and more developers see the performance improvements that TPH can deliver, we're seeing wider adoption and increasingly innovative applications.
It sounds like TPH is gaining traction and is ready to play an even bigger role in the future of computing. But before we dive into that, let's recap some of the key takeaways from this part of our exploration.
We looked at different types of TPH hints, each serving a specific purpose in optimizing data flow, from the basic no steering tag mode to the more specialized interrupt vector and device-specific modes.
We also got into the details of hint generation, encoding, decoding, and how these hints are used by various components in the system to make intelligent decisions about routing and processing data.
And we talked about how important accurate hint generation and efficient hint processing are, along with system-wide coordination, to maximize the benefits of TPH.
We saw how TPH can cut down on latency, improve bandwidth utilization, and even enhance power efficiency. We explored real-world examples of how it's making a difference in everything from supercomputers and data centers to the devices we use every day.
And we delved into how TPH interacts with other PCIe technologies like SR-IOV and ATS to create a truly optimized environment for data flow.
Well said. I feel like we've significantly expanded our understanding of TPH.
We've covered a lot of ground, but there's even more to uncover. In Part 3, we're going to examine the broader implications of TPH, explore its potential impact on the future of computing, and dive into some of the security considerations.
Okay, I'm ready to wrap this up and see what the future holds for TPH. Join us for the final part of our journey, where we'll connect all the dots and see how this technology is shaping the world of computing. Welcome back for the final part of our TTH deep dive. We've explored the basics, gotten into the technical details, and now it's time to zoom out and look at the bigger picture.
Exactly. We've seen how TPH optimizes data flow, boosts performance, opens up all sorts of new possibilities, but there's still more to consider. Where does TPH fit in the grand scheme of things? What are the bigger implications?
That's what I'm really interested in. We often get caught up in the potential of new tech, but we also have to think about the downsides. Security, for example, is such a big concern these days. Are there any specific risks with TPH?
That's a really important question. So far, there haven't been any security vulnerabilities directly tied to TPH. But it retains a relatively new technology, and the security landscape is constantly changing.
So, like any tool, it can be used for good or for bad. We have to be aware of those potential risks.
Exactly. TPH involves accessing and manipulating data, so robust security measures are absolutely essential. Things like access controls, strong authentication, encryption protocols, that kind of thing.
So making sure that only authorized users and devices can mess with TPH settings.
Absolutely. And staying up to date on security best practices and knowing about new threats is critical.
Because hackers are always trying to find new ways to break into systems, and a technology like TPH could be a tempting target.
Unfortunately, that's true. But if we take a proactive approach and build security in from the start, we can minimize those risks and ensure TPH is used safely.
So it's a shared responsibility from the developers who create TPH to the people managing the systems and even the users.
Right. Security has to be a top priority, especially as TPH becomes more widespread and gets integrated into our systems. But let's focus on the positive side for a bit. We talked about the performance gains, but what about the impact of TPH on the future of computing as a whole?
That's what I'm really excited about. It feels like TPH could lead to some big changes in how we use technology.
I think so too. I see TPH as a foundational technology, a building block for a future where computing is just seamless, intuitive, and responsive. As we rely more and more on data, TPH is going to be essential in making sure it all flows smoothly between our devices and systems.
It's like TPH is creating this data superhighway, getting rid of bottlenecks and letting information travel at lightning speed.
That's a great way to put it. This has huge implications for everything, from artificial intelligence and machine learning to cloud computing and the Internet of Things.
So TPH isn't just about making our current computers faster. It's about building the foundation for the next generation of technology.
Exactly. TPH is a fundamental piece that's going to support a lot of the progress we see in the coming years.
That's really exciting. Are there any areas where you think TPH will have a particularly transformative impact?
Edge computing is a big one.
Remind me what edge computing is all about.
It's all about processing data closer to the source instead of sending it all the way to a central cloud. So bringing the processing power to the data, not the other way around.
So instead of sending your data to a faraway server, you can process it locally on your device or a nearby server.
Exactly. This has some big advantages. Lower latency, more efficient bandwidth uses, and better privacy and security.
It sounds like TPH and edge computing were made for each other.
They really were. TPH can optimize data flow and how resources are allocated in these edge computing setups. This ensures data gets processed quickly and effectively right at the edge where it's needed most.
So TPH is helping to bring the power of computing closer to the user, making everything more responsive and personalized.
That's the idea. This opens up incredible possibilities for so many things. Self-driving cars, smart cities, personalized healthcare, augmented reality, you name it.
It really seems like TPH could change the way we live and work and interact with the world around us.
I think so too. And it's not just about the technology itself. TPH could have a big impact on the economy and create new opportunities.
Really? How so?
By helping businesses to create more efficient and responsive systems, TPH can boost productivity, reduce costs, and lead to new products and services.
So everyone wins, businesses and consumers.
Exactly. TPH is a game changer with the potential to change the entire landscape of technology.
It's amazing to see how something that started out as a way to optimize data flow could have such a huge impact on so many different things.
It really shows the power of innovation. Sometimes what seem like small steps forward can lead to giant leaps down the line.
Well said. As we wrap up our deep dive into TPH, I want to leave our listeners with a few key thoughts. First, TPH is a powerful technology that's already making a big difference.
It's optimizing data flow, boosting performance, and creating new opportunities.
Second, TPH is still evolving, and we've only scratched the surface of what it can do.
As data needs grow and new technologies come up, TPH will play a critical role in shaping the future of computing.
And finally, TPH is a reminder that innovation is an ongoing process.
We need to keep looking for new ways to improve, optimize, and push the limits of what's possible.
So to all our listeners, we encourage you to stay curious, keep exploring new ideas, and never stop learning. The world of tech is constantly evolving, and there's always something new to discover.
Who knows? Maybe one of you will be the one to develop the next big thing that changes everything.
Until next time, keep diving deep.